on and go. We're going to talk about motion today. Motion. And you already know how to do part of this, even if you weren't here yesterday. And we are going to say that this is the position of a particle. We're going to say that the position is measured in meters and that the time is measured in seconds. Jacob, what do we do to find the velocity of the particle?
Take the derivative of the function.
I told you knew how to do this. And so therefore the velocity at time t is equal to 18t minus 3t squared. Very good with that? Acceleration is the second derivative. So yesterday our lesson was about higher derivatives, and we found the first and the second derivatives. Acceleration is the derivative of velocity, and we get 18 minus 6t. Very good with that? I'm going to look at the velocity function, and I'm going to look at the acceleration function. What shape does the velocity function make? Right side up or upside down? Upside down. If I factor out a 3t, I get 6 minus t. And so I can see that this parabola goes through 0 and through 6. 0 and 6. So the question is, when is the velocity positive? From 0 to 6. Everybody good there? When is the acceleration positive? The acceleration is going to be this graph. What shape does that make? A line. Right side up or upside down? Down. It's going to start up at 18. It's going to head like that. I just need to find where it crosses the x-axis. And I can find that if I set it equal to 0, 18 minus 6t is equal to 0. Or 18 is equal to 6t. So time is equal to 3. So it's at this spot that the time is equal to 0. Or that the acceleration is equal to 0. So the acceleration is positive from where to where? Good. Now, we want to talk about something speeding up or slowing down. So this is the new part. It's not complicated, but I need to make sure that we discuss it, okay? So, a particle can do really 4 different options, okay? I'm going to make a movement. You tell me, is my velocity positive or negative? And am I accelerating or decelerating, okay? You ready? Velocity positive or negative? Positive. Accelerating or decelerating? Decelerating. So was I speeding up or slowing down in that situation? I was slowing down. Okay. Try another one. Velocity positive or negative? Positive. Acceleration? Positive as well. So I was accelerating, right? So was I speeding up or slowing down? Speeding up. Notice that when the velocity was positive and the acceleration was positive, I was speeding up. Watch this one. Velocity positive or negative? Negative. Was I accelerating or decelerating? It was accelerating. My acceleration, though, was negative because it has direction as well. I was speeding up in that scenario, wasn't I? Velocity was negative and acceleration was negative. When they are of the same sign, they are forces that act together and help you speed up. When they're opposite signs, they're forces that act against each other and they slow you down. So I'll do the velocity that's negative, but acceleration that's positive. Watch this. This is velocity negative, acceleration positive. Okay? And then all of a sudden when I get to here, now velocity and acceleration become positive both. So if they're the same sign, speeding up. If they're opposite signs, they're slowing down. So we want to find when this particle is speeding up. So what I'm going to do is I'm just going to make a little chart here, and I'm going to plot velocity on the top and acceleration on the bottom. And I'm going to start with 0, and then I'm going to plot the points 3 and the point 6. Because that's where velocity or acceleration change. And I'm simply going to identify where they are positive and negative. So from 0 to 3, is the velocity positive or negative? Positive. How about from 3 to 6? Positive. How about 6 to infinity? Negative. Now we look at the acceleration. The acceleration starts positive, then it flips to negative, and it stays negative. So when the signs are the same, it's speeding up. So the particle is speeding up from 0 to 3. Union 6 to infinity. When is the particle slowing down? Well, that's when they would be opposite signs. So from 3 to 6. How's that? Okay. What is the distance the particle has traveled over the course of the first 8 seconds? We always look at the start. We look at the change, and then we look at the end. The time and the position. It starts at time 0. At what time does it change direction? 3 and 6. So we have 2 spots where it changes direction. It ends at 8. Please take out your calculator. Uh-oh. I don't know who these people are. Hi! How are you?
Good.
Great. Thank you so much.
Yep.
Abby Meyer. Okay. Very good. Thank you. Are they seniors?
Yeah.
Okay.
Someone's gonna hear that.
It's okay. Danny, can I just say that you have really flipped over like a new leaf? Like,
I feel like a new
how are you doing this? Like, how are you accomplishing this task?
Your clocks for daylight
That's funny. That's good. I like that. All right, so we're going to type in, it's 9x squared, I believe. Is it minus x to the third?
Yeah.
Okay, so that's what we have. And we want to figure out the position. So I go to my table, and I simply type in 0, 3, 6, and 8. So I got 54, 108, and 64. Can you give me those 3 numbers again?
0, 54, 108, 64.
Thank you. So it starts at 0, it goes to 64.
54.
My bad. 54, then 108, 64. Thank you. 0. So it does that thing.
Whatever that
No,
means.
it goes.
Well, what do we got? 54.
It goes
It
all
goes all the way to
back
108, then it just goes
64.
back to 64.
So 0 to 108, 64.
There you go.
Oh, I'm sorry.
Oh, jeez.
Like, what's going on? Because I'm like, how is it like it changes direction? Silly me. The one that talks about the change of direction is the velocity, not the acceleration. We don't care about the number 3. We only care about the number 6. Okay? Sorry about that. It's like, what's going on here? Why? So it changes direction at time 6, and then it ends at time 8.
Okay.
So that helps us out. We start at 0, we go to 108,
So go back.
And then go back to 64.
and then back to 64. That's the motion of our particle. 54 has no part of it, really. And so we can see that this moves 108 units, and then it moves another, whatever 108 minus 64 is. Somebody want to do 108 minus 64 on the calculator? 44. And I get a total of 152 meters.
52.
How's that?
For the velocity and acceleration, how would we, like do meters per second or?
Yes, got it. So if it said, what is the, what is the velocity at time equals 6, you would say 0 meters per second. If you say, what is the acceleration at time 3, you'd say 0 meters per second squared. The label for acceleration is the denominator squared. Okay. All right. I want you to, we don't need to do the second example. We would like you guys rather to just focus on working on, we'll do the second example tomorrow. We'd like you to start working on 2 of these problems within your homework. Okay?
I got that stuck in my mind.
I know, I can't think the whole hour. I can't.
I know.
They'll come out on my
Yep.
side then.
So I would work on problem 1 and 2 right now. Problem 1 and 2. 3 and 4 we'll save to tomorrow. We'll use our calculator on it. Okay? You guys have the rest of the time to work.